Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others who want to test their math skills with these types of test questions. And this will be our 18th part in this series. So what we have today is a little bit of calculus, and we have to perform the following derivative for this expression shown. And it looks like we are doing the 8th derivative here for this entire expression that involves x to the power of 10 divided by 10 factorial minus x to the power of 9 divided by 9 factorial plus 8, or x to the 8th over 8 factorial minus off x to the 7th over 7 factorial. All right, so taking the 8th derivative would be a little time consuming. So what we're going to do is we're going to take the first and second derivatives and possibly the third derivative to see if some kind of pattern emerges here that we can take a shortcut to get to the 8th derivative. Now, if you wanted to, you could just take all 8 derivatives, but that would be a little bit more time consuming than what is required. So all these expressions is that we are going to take the derivative of each individual one because they are separated by pluses and minuses. So each portion here is of the form of derivative with respect to x of a times x to the power of b, where the derivative of this expression would be b times a times x to the b minus 1, where a in this case would be 1 over that factorial number. So taking our first derivative here, which I'm just going to abbreviate that as DER. So our first derivative would be equal to 10 x to the 9th over 10 factorial minus 9 x to the 8th over 9 factorial plus 8 x to the 7th over 8 factorial minus off 7 times x to the power of 6 all over 7 factorial. Keeping in mind, we are keeping with this form where a is my constant, and that is my 1 over factorial number. And then we have x to the b minus 1 multiplied by the previous power. So can we reduce these individual portions at all? Well, yes, we can. We can reduce them by a little bit here. Since, I'm just going to look at my first one here because this will apply to the other three. So I'm just going to look at my first term of 10x to the 9th over 10 factorial. So since 10 factorial is equal to 10 times 9 factorial, what we can do is that we can separate this out into each portion, just looking at the first one of 10x to the 9th over 10 times 9 factorial, and the 10s would drop out. We would repeat that process for each of these because it'd be 9 over 9 times 8 factorial, 8 over 8 times 7 factorial, and 7 over 7 times 6 factorial. So this first derivative actually simplifies down to x to the 9th over 9 factorial minus off x to the 8th over 8 factorial, and then plus x to the 7th over 7 factorial, and then minus off x to the 6th over 6 factorial. So you may see a pattern that is already starting to emerge, but just in case you are not seeing it just yet, just take the second derivative. So we're going to take the derivative of this portion right here, which would be our second derivative, and let me label that real quick. So our second derivative would just be the derivative with respect to x of what I just wrote. So let me just rewrite that of x to the power of 9 over 9 factorial minus off x to the power of 8 over 8 factorial plus x to the 7th over 7 factorial minus off x to the 6th over 6 factorial. So once again, keeping with that same process of a x to the b with our derivatives, we're just going to take the individual derivatives of each of these, carrying the pluses and minuses through. So our first term becomes 9x to the 8th over 9 factorial minus off 8x to the 7th over 8 factorial, and then plus 7 times x to the power of 6 over 7 factorial, and then minus off 6 times x to the 5th over 6 factorial. And then once again, we can do the same process again because we would have 9 factorial is equal to 9 times 8 factorial, and so on and so on. So the 9s would actually drop out. So my second derivative, once you do that process for each of these terms, you would end up with x to the 8th over 8 factorial minus x to the 7th over 7 factorial plus x to the 6th over 6 factorial minus off x to the 5th over 5 factorial. Well, there is a pattern forming here, and if you didn't see with the first one, you can probably see with the second one now. And we could use this pattern, or we could just go along and just take the 8th derivative like what we're doing and just force it all the way through. Or we can take the shorter path and use the pattern that is forming here. So what we have with our pattern is that, think of it like this. So after our k amount of derivatives, where the k is just the number of derivatives that we are taking, we would have a term that looks like this, where we have x to the n over n factorial would change to this variable format after you take your k amount of derivatives. This expression, which is our starting expression, changes to x to the n minus off k all over n minus k factorial. So since we are looking for the 8th derivative, well, we would just plug in k is equal to 8. So let's go ahead and let's just jump all the way to our 8th derivative. And there is a little something that you have to watch out for. So taking the 8th derivative from our starting expression, which I'll just rewrite right here, of x to the 10th over 10 factorial. Don't forget about these pluses and minuses. And then you would have 9, or x to the power of 9 over 9 factorial plus x to the 8th over 8 factorial, and then minus off x to the 7th over 7 factorial. So applying this rule right here, or this pattern, this is what we would end up after completing the 8th derivative for each of these little terms inside here. We would have x to our original power of 10 minus off the k, so 10 minus 8, all divided by 10 minus 8 factorial. And then repeat that process for each of them, keeping the 8 as your constant k. So x to the power of 8 over 9, or 8 minus 9, sorry. And then 9 minus 8 factorial. And then plus x to the power of 8 minus 8, all over 8 minus 8 factorial. And then minus off x to the 7th minus 8 divided by 7 minus 8 factorial. All right, what do you see here that does not really make much sense? Well, the first 3 terms, yeah, they make pretty good sense. But what about this last one right here? This last one does not make a whole lot of sense going on here. And this is the reason. So let's focus on finding the 7th derivative for this portion right here, and you'll see why this last one doesn't really make a lot of sense. So focusing on this last one only, let's find the 7th derivative here of minus, or actually we don't need the minus sign. Let's not put the minus sign there. It'll just be x to the 7th over 7 factorial, because the minus sign doesn't really matter. It's just a constant. So finding the 7th derivative of this expression, keeping with that same formula that we are going with our pattern, this would be x to the 7 minus 7 all over 7 minus 7 factorial. Well, this would just be x to the 0, and this would just be 0 factorial. Well, what is 0 factorial? Well, 0 factorial is just 1. What is x to the 0? That is just 1. So essentially with the 7th derivative of this last term here, we have 1 over 1, which is just 1. So if you were to take another derivative going to the 8th derivative over all, what is the derivative of just a constant number? Well, since it doesn't have a variable with it that you're taking the derivative with respect to, the 8th derivative of this would just be 0. So this is why this last term does not make any sense. It completely goes to 0 when you're looking at the 8th derivative. And that is something you have to watch out for with this type of jumping when you go all the way to the very last derivative using a pattern form. You have to make sure that all the derivatives make sense after you complete the pattern. So essentially what we have here is our first one's okay, second one's okay. Last one, we're going to have to do a little bit of editing here. And then this, or the second to last one with the 8th, do a little bit of editing. And this last one with the 7th in the beginning drops to 0 during the 8th derivative. So essentially, if we simplify this entire expression down, we end up with, well, x 10 minus 8 is just x squared. 10 minus 8 factorial is just 2 factorial. Subtracting off just x over 1 factorial, and then plus 1 over 0 factorial. Well, 0 factorial just is 1. So this is just be 1 over 1. And then 1 factorial is just 1. And then 2 factorial is just 1. Or sorry, no, 2 factorial is 2. So we would have 1, 1, and 2. So essentially what we have here is x squared over 2 minus x over 1, which just becomes x, and then plus 1 over 1, which is just 1. And that would be my 8th derivative, taking that shortcut with that pattern. Now, as I said earlier, you could just go ahead and take all the way to the 8th derivative, just taking like the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th, if you want to do it that way, a little bit longer. Or you can take this pattern way, just keeping in mind that you have to watch out for constants appearing throughout. So that's how you would solve that problem. And I hope you enjoyed the video and learned a new math skill from it along the way. And if you want to test your abilities even further, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.